Okay. Hello, everyone. Welcome. I am actually in Terminal 1 at San Francisco Oakland International Airport, which is on the San Francisco side of the bay. And I'm in Terminal 1, and your extra credit opportunity, just to show you, you can see out there, maybe it's kind of bright, but there's the runway out there and the gate and stuff. Anyway, your extra credit opportunity for this lesson is to tell me who this terminal is named after. Again, it's Terminal 1 at SFO, San Francisco Oakland International Airport, and what that person is famous for. All right, let's go ahead and get into 401. So I'm going to share the notes and let's get started. So you can see here, you guys are going to warm up by graphing the linear equations in a coordinate plane. And notice that first problem. We'll go ahead and do them, and then let's see how it turns out for you. Okay, so hopefully when you graph these, looks something like this. Black one here is already in what form, right? Y equals mx plus b, slope-intercept form, where our slope is 3/4, which means rise 3 and run to the right 4, or fall 3 and run to the left 4. So if I went to 0, 2, because that's my y-intercept point, I go to 0, 2, put my point there, go up 3 and over 4, or I could have gone down 3 and to the left 4. Either way, it would have been on that black line. Okay, hopefully for this one, number 2, you recognize it's y equals -1, which means it is a horizontal line with every single point have an ordinate, a y coordinate of -1. And then for x equals -2, we know that that is a vertical line with every single point on the coordinate plane that has a x value, an x coordinate of -2. Okay, awesome. All right, so for this, you need to describe whether the table represents a linear or nonlinear function. Remember how to do that? Oops, so remember it's got to be a constant rate of change. So try them. Okay, hopefully you got this was linear. As x goes up 1, y goes up 5. Okay, what about the second one here? Right, non-linear, right? As x goes up 2, y goes up 6, and then 2, and then 4. That's not a constant rate of change. All right, so our learning target is if I have a graph of a linear function, then I will know how to write the linear equation of the graph line. So before we were going from the equation to graphing the line, now we're going to go the other way. And we're going to go from having the graph and writing the equation. And I'm thinking you guys probably can't see me all that well. That view out there is not the greatest. So I'm actually going to turn and go this way, maybe get more light so you guys can see me a little bit better. Yeah, that's better. My beautiful mask. Anyway, all right. So again, you can work with a partner if you want to, if you're doing this in breakout rooms. If not, doing it on your own, that works too. Okay, so what you want to do is find the slope and y-intercept of each line, okay? And then write an equation in slope-intercept form. And then you can go and use Desmos, your online graphing calculator, to verify your equation, okay? So what would be the slope? Well, going from this point to this point, how many do we rise and how many do we run? We rise 1, 2, 3, 4, and we run 1, 2. So what would that be? Yeah, 4/2, which reduces to 2/1. What's the y-intercept? Remember, it's where the line crosses the y-axis. It's the y-coordinate, so it'd be -1. So if we're writing this in slope-intercept form, which is what again? Y equals mx plus b, all we do is plug 2 in for m, -1 for b. So what would it be? Y equals 2x minus 1. Okay, try this one now. Easy to find the y-intercept, right? Just look for where it crosses. So hopefully you got 2 for that. And what's the slope? We went down 4, so that's -4, and then to the right 4. So what would that be? -1. Good. So what would the equation be? Y equals -1x or negative x plus 2. Okay, so graph shows the cost of a smartphone plan. Again, when you get a graph, make sure that you really analyze it carefully. Okay, so notice that the horizontal axis is just talking about data usage in megabytes, and the y-axis is cost per month. Okay, in dollars. Okay, so what's the y-intercept of the line? So where does the graph, where does this ray, notice it doesn't go into the second, third, or fourth quadrants, right? Where does it cross the y-axis? Okay, 0, 20, so it's 20, right? What does that mean? Think about what that means in terms of data usage and costs. And hopefully you said then it means $20 for your smartphone if you use 0 data. In other words, you don't use it at all, right? Okay, or you're only using Wi-Fi. Okay, B, approximate the slope of the line. Interpret the slope in the context of the problem. Okay, so how could you go about doing that? Think about it. Couldn't you find 2 points and then figure out what the rise is over the run? So we have one point at 0, 20. Where do we see another one where it kind of crosses? Let's see what I did here. So I said that if you went out to 2000, then you were here at 80, right? So at 2080 would be the coordinates of that point right there. So if you think about it, we would go rise from 20 up to 80, so that's 60, right? And what's our run from this point over to that point? It would be from 0 to 2000. So our slope would be rise of 60 over a run of 2000, which we then would reduce, right? So we cancel a set of zeros and have 6 over 200 and then divide those by 2 and we get 3 over 100. So what does that mean in terms of the word problem here? Hopefully you're saying that for every 100 megabytes, it costs $3, okay? Okay, so now let's write an equation that represents the cost as a function of the data usage, right? Because isn't it true that the more data you use, the higher the cost? Okay, so think about it. We're gonna use what form? Right, y equals mx plus b. So what's m? Right, 3 over 100 or 0.03. And what's our b? 20, exactly, right? Remember, because it's right there, 20. So what's our equation? F of x equals 3 over 100x or 0.03x plus 20. Awesome. Okay, so here I want you to write an equation of each line with the given slope and y-intercept. Yes, you should be saying, wow, this is easy. It is. All you're plugging in is the slope for m, the y-intercept for b. Simple as that. So go ahead and do those. So hopefully you got y equals -3x plus a half. And for this one, with the slope of 0, would we want to leave it like that or would we want to change it? Yeah, we want to change it. Y equals -2. Okay, so what that's telling us is that we could still use y equals mx plus b for a horizontal line because a horizontal line is not going to have any slope. But usually you could just write it as what do all the points have in common? They all, in a horizontal line, they all have the same y coordinate, in this case, -2. Okay, so let's take a look at this. Write an equation of each line in slope-intercept form. And I've kind of given you, remember what slope is, m, rise over run, the change in the y coordinates over the change in the x. So if we're looking here, and let's use this. So what are our y coordinates for these 2 points that they have selected here? Aren't they 3 and -3? So you could write this as 3 minus -3 over, what are the x coordinates? 4 minus 0. So what's 3 minus -3? 6. What's 4 minus 0? 4. What does that reduce to? 3 halves. What's our b? What's our y-intercept? Right there, -3, right? So all we have to do is plug it in. Okay. Now you might be saying, well, what if, Mr. Kalin, what if we went from this, we've subtracted these coordinates from, or these coordinates from these coordinates, went the other way? Well, then wouldn't we have had -3 minus 3 over 0 minus 4, which would get us what? Wouldn't that get us -6 over -4? And what does that simplify to? 3/2. Okay, let's try this one. Notice it's sloping down to the right. What does that mean in terms of the slope? Right, it's got to be negative. Okay, great. So figure out your change in your y coordinates over the change or the difference in your x coordinates. So in this case, I went -1 minus 2 over 4 minus 0. Notice I'm always consistent. If I'm going to start by subtracting with the y's using this one, then I'm going to start subtracting the x's using this one. So what does that simplify to? -3/4. Good, it's negative. That's what we wanted, right? And what's b? 2, right? So write it in the equation. Y equals -3/4 x plus 2. All right, awesome. Okay, so now I'm not even going to give you the graph. Do you need it? No. Again, here's the formula. Use the same thing here. So give these a try. Just make sure you subtract the y coordinates from the x coordinates, being consistent in like where you start for each of them. Okay, so I did -1 minus 5 over 0 minus -3. -1 minus 5 is -6. 0 minus -3 is 0 plus 3, which is 3, reduces to -2. What's b in this case? Oh, hey, I've got a y-intercept, right? How do I know it's a y-intercept? Because the what is 0. My x coordinate is 0, which means I'm on the y-axis. So b is -1, and then just plug her in. Simple as that. Y equals -2x minus 1. Okay, so look at your points that you have here and do this one here. You may notice something interesting with this one as you go through it. Did you get a slope of 0? Yeah. -5 minus -5 is like -5 plus 5, which is 0. Okay, and then continuing on, what's my b? They gave me a y-intercept point, 0 comma b, right? So it's -5, and then just plug it in. And like I said, you may have recognized that both y coordinates were the same, so it has to be a horizontal line, right? So you could have gone straight to here, realizing, oh, it's going to be the line that has every single point in the known universe that has, in the coordinate plane at least, that has a y coordinate of -5. Okay, so write a linear function with the values f of 0 equals 10 and f of 6 equals 34. Okay, so remember what f of 0 means. That means when x is 0, y is equal to 10. So our ordered pair would be 0, 10. Well, if that's the case, what does f of 6 equals 34 mean? It means when x is 6, y is 34. Yeah. Okay, well then don't we just have 2 points and we can just apply this? So we could go 34 minus 10, that's the change in the difference of the y's over the difference in the x's, 6 minus 0. That reduces to 24 over 6, which reduces to 4. So what would our equation be? 4x plus 10. Good. Ooh, they're getting ready to start boarding my flight. Better move on. Okay, write an equation of the line in slope-intercept form. Okay, so again, m and b, we know slope-intercept form is y equals mx plus b. So go for them. Okay, hopefully for this one, you got b was 1. Your slope is, in this case, what? It's 2 or 4 or 1/2 or 0.5. Threw it in the formula, and there you have it. Okay, for this one, go for it. All right, well, hopefully you notice your y-intercept was -1. Slope down 2 over 5. So what's that slope? -2/5 or -0.4. Either one's fine, decimals, fractions. And that's what we have. How could you check these, by the way? Shouldn't, if you plug in any of these points for x and for y, shouldn't they work? Let's see if that's the case. If I plug in 5 here, isn't -0.4 times 5 -2? and then -1 would be -3. And isn't that what I would plug in for y? Okay, so now I want you to write an equation of the line that passes through those 2 points, or coordinates, the points that have those coordinates. Notice that one of the points is what? Yeah, it's a y-intercept. Now you might be thinking, well, what do I do if that's not the case? Well, that'll be in our next lesson. Okay, so hopefully you realize I got to figure out the slope. Always have to have a slope and a point. So to figure out the slope, we go 10 minus -2 over 4 minus 0. And again, we could have gone the reverse way, and then we would have gotten -12 over -4. Either way, it reduces to +3. So m equals 3, and b is -2, right? Because anytime you have a point that has coordinates of 0, comma something, you know that's where the line crosses the y-intercepts. That's your y-intercept. And then write it as a formula. So it would be y equals what? 3x minus 2. Good. Okay. So I gave you a little hint on this one. I think this box was supposed to be covered up, but that's okay. Write a linear function g with the values g of 0 equals 9 and g of 8 equals 7. Just remember what that means. It just means that when x is 0, y, or g of x, either way, is 9. So what are our 2 points? 0, 9, 8, 7, and then from there follow the same path here. Go for it. Okay, I'm back. So hopefully you got the slope, change in the y coordinates over the change in the x coordinates. B was 9, right? 0, comma b, right? And then plug it in. All right, awesome. What do you do if you're given a point that's not a y-intercept? Like I said, that's coming up soon. Okay. All right. Excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours of electricity in 2007. 5 years later, by 2012, the amount of electricity generated had increased to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropower renewable energy sources as a function of the number of years since 2007. So our base year is 2007. Use the model to predict the number of megawatt hours that will be generated in 2017, which would be what? 10 years after that. Okay. So let's assign and define a variable. What should x represent? Hopefully you said the number of years since 2007. Okay. Okay. So what are we going to do in terms of figuring out how to get this? Well, what is f of x? F of x represents what? Hopefully you're talking about the millions of megawatt hours, right? Okay. So what is 1 point? Remember, our base year is 2007. So our x0 year, right? Or where x equals 0 is 2007. So isn't one of our points going to be 0, comma, and then remember the number of millions of megawatt hours in that first year was 105, right? So 0, comma, 105. We're doing this in millions, right? It's in millions. What would be your second one for 2012? That would be 5, comma, 219. Well, don't we have 2 coordinates now, or two points with ordered pairs? Can't we just subtract the y coordinates and then put that over the difference of the x coordinates? You betcha. And if you do that, we get 22.8, okay? So what's b in this case? Boom, right? So what would be our function? F of x equals mx plus b. Well, m we know is 22.8 and b is 105. Okay, so then the part was use the model to predict the number of megawatt hours that we generated in 2017. Well, we said that that's what? That's where x is 10, right? Because it's 10 years after 2007. So what would we do to figure out how many million megawatts? Hopefully you just said plug in 10 for x. And if you do that, you get 333. Now it's in millions, right? So million megawatts. Okay. And I'm actually probably going to have you guys watch that SEM video with me in class. So that, my friends, does it for that lesson. So I'm going to sign off from beautiful SFO Airport Terminal 1. Bye-bye.